Hi, I'm Jadi, and this is Introduction to Network, and we are going to speak about the NATS, Network Address Translation, if I'm not mistaken. No, I'm not. Ha. We had two issues with the traditional networks, which forced us to start having something like a NAT. The two issues were IP version 4 were very limited. Nowadays, I'm connecting my dog, my toaster, my lamps, my switches, my TV, and my laptop, my PC, my phone, my tablet to the internet at my home, only using one router. And this is connected to my ISP, and the ISP is connected to the internet. So in the beginning days of the IP, they have not thought of this. Now I have 10 devices here, and all of them needs to have an IP and connect to the internet. As you know, and as we discussed, we are using private IPs like 10.1.1.1, 10.1.1.2, 10.1.1.3, and others to connect here. And this is done by my router. It has a DHCP which provides these IPs, and there is one IP here, say 10.1.100 as a routing default route, and all of these connect here. My ISP normally gives me an IP which is valid here, like 5432. But all of these devices needs to connect to the internet. Say you want to go to the jadi.net. Okay, here I make a request. My web browser says from the source to this destination with this data. What is it? My source is 10.1.1.1 here. It wants to go to the jadi.net. So this will be the IP of the jadi.net. And this is the data which is give me the first page of jadi.net. This we should reach here to the jadi.net server, and this should answer back. But what's the problem? This IP is not valid. This cannot be routed inside of the internet. Here, NAT happens. On this level, my router will translate this packet to source, destination, and data. The source will be 5432, its own IP. The destination will be the same, jadi.net, and the data will be the same. We will talk about it later. So when the server gets this, it sees that 5432 is asking for the first page. Okay, so it will answer back with source, destination, data. Now the source is jadi.net. This is the answer. I'm sending data as the server of jadi.net to this NAT device, to your router. So this will be 5432. And the data will be the data under my first page. This will reach to the NAT device. NAT device will get it and see, okay, I had this request for this device. So let's translate again. I won't change the source address because it's still jadi.net. But the destination now, I will change 54, which is my public IP address on my NAT device, to the computer who asked for this data. So that will be 10.1.1.1, and the data will be same. This is the general logic of the NAT. It's practically translating the address from internal, invalid, private IPs to the public, valid IP addresses, and vice versa. So we had to invent this to prevent not having enough IP version 4, and also for the complications of the routing. We need to scale our routing. On the beginning days, routing protocols were not that good. They were not able to route everything from anywhere to everywhere. So they had to reduce all these machines to this one routing IP address. Okay, this is the general idea, but there are some more details. Normally we speak about two different kinds of NATs. Traditional NATs and we can call it PAT. We will talk about it later. On the traditional NAT, the issue is not practically resolved. I have some devices here with their private IP addresses, non-routable, and I have one NAT device here. On the traditional method, my NAT device should have enough IP addresses to translate each of these IP addresses to the new one. So for example, I need this one here and 5434, for example. If this device wants to go out, my NAT device will translate its IP to this. It will go do whatever it wants. When returning back, it will see this IP, and in a table, it memorized that, okay, 32 was for 11. So I will change back and will give the data to this one. If this device wanted to go out, I would use my next IP. We can see this is not that useful. Why? Obvious. Because I need as many as private IP addresses. I need to have the same number of public addresses. So it's not resolving any real issue for me. So we move to the path. Path is kind of, we can call it network port address translation. So that would be NPAT. Many people call it only PAT. Okay, how this one works. Imagine I have 3 devices. Same situation. 10, 1, 1, 1, 1, 2, and 1, 3. And I have one NAT device here, which is technically an NPAT device. Okay? Whenever you want to contact a server, you should use ports. So if I have an internet here and I want to connect to the Jedi.net, practically if it's a web server, you are connecting to port 80. The source port is a random port, so it can be 2915, for example. So when you want to connect here, the NAT device will use only one public valid IP address here, like this one. But when it wants to translate yours to the destination address, it will use its own IP address, 588, from another random port. So it can go from 9651. And it remembers that, okay, 2955 from the server 11, I translated it to 9651 port. This is it. So you will go out from the port 9651 from the public IP address toward this. When returning back, the NAT remembers, okay, if someone is talking with this one from my table, okay, I have to provide it here. At the same time, if you have another connection from 6917 toward another server, the NAT device will add, okay, say from 10112 port 6917, I have translated this to another random number, say 32145. This can be up to 65,000. So this will go out with 5321, same IP address, but from this port. So whenever someone answers back to this, I will provide it to this one. As you see here, I can have as many IPs as I want, say up to 65,000, and I will use only one address to translate them, but with different ports, keeping a table like this. This is PAT. This is practically what happens on your network. Normally, on your network, if you are connected with a DSL or something like it, you have some devices here, you have your router, your box here, one valid IP address here provided by your ISP, and your ISP is connected to the internet. Whenever anyone wants to go out, they will use their private address. Then your NAT device will use its own public address, can be something like this, by adding a port, keeping the table, and will take your data out, return back, and do the translation and give it to you. But there are still some small issues. As we said, when you are sending data out, your machine sends it like this: source, destination, and payload. So it says from 10.1.1, I'm sending to juddy.net. For the web server, I want this data. Your NAT will translate it to a new packet. On the new packet, the source is the public address of your NAT device. So it would be, for example, 5432, and you are contacting juddy.net with this data. The server will get this, will answer back, the translation will happen. But in some cases, like FTP, for file transfer protocol, or SIP, your IP address also is used in your payload. In a traditional FTP, you will say, I want this file, please send it to 10.1.1.1. So if your NAT device only changes this, it won't be useful, because the server cannot answer back to this. So your NAT device should also check the payload and change it and all the stuff. This is very difficult and tiresome. So, for example, on the FTP case, you have one command which is passive. You will tell, okay, just act passive. You don't need to contact me on any IP address. I will contact you again. Because again, you can contact and say, okay, give me the file, and on the same connection, you can get it back using your NAT devices. There is a very one cool RFC, which is called NAT friendly RFC. I will search it in Google for you. This is it. This will describe how to write programs to be NAT friendly. In short, it is do not use your IP address anywhere. So use other stuff. For example, on a peer-to-peer devices, I will speak about this later. But for example, use DNS names, not IP addresses, because IP addresses may change. But your DNS name is same even after the NAT, because the DNS most probably will reach the NAT, NAT will contact you. Or for example, the main issue happens when you are writing peer-to-peer applications. Two softwares want to speak directly with each other, not with the server. If they are behind the NAT, they cannot. We will see how you can solve this. But let's describe it a little bit more. The issue is if you have a server behind the NAT, this is your NAT device, this is your server, this can be your home. Otherwise, this can be your network. You can have a network NAT. And this is the internet. We saw that whenever you want to reach someone, the NAT will resolve it for you, will give you back the answer. But what happens if someone directly needs to contact you? For example, you are running a web server here and you want people to be able to reach you. Directly they cannot, because your IP is not valid. For example, this is your IP address. You have a valid address here. This can be, for example, I don't know. For example. So if they reach to this port 80 for a web server here, someone from the internet, from his home wants to reach you, but your computer is not responding because this is your IP. And she's using this one. So what should be done? There are few ways to overcome this limitation. One, okay, they are called port forwarding, port mapping, or more technically DMZ, demilitarized zone. This is your militarized zone. No one can enter it. If you want to demilitarize it, maybe if you go to your router, you will find one of these configs, port forwarding, port mapping, or DMZ. Here you can say, whenever it reached you on port 80, forward its data to this IP address, port 80. This way, if someone uses this address in his browser or her browser, they will reach here, so they will reach your NAT device. You have a configuration which says port 80 should be forwarded to this machine's port 80. So whoever puts this in the browser, they will see your port 80. If you want, you can fiddle with your machine, with your router, and you may find this configuration. But the issue, sometimes it's larger. We have service provider NATs nowadays. Also, we have CG NAT, carrier grade NAT, especially on the mobile networks. Because in the old times, it was only your computers. So they could give one of their customers one valid IP. But now you may live in a country with, I don't know, 30 million, thousands, millions of mobile phones, and your phone provider, your cell provider, like O2, wants to provide internet to all of these. So they have a CGNAT active. For the CGNAT, they will have a pool of IP addresses, and say 100 IP addresses connected to the internet. But any of the users, especially on their phones, they will get only private addresses, and they are all go with this pool of addresses. This makes your life more difficult if you want to run a server on your phone. Most probably you won't be able, because you are behind a CGNAT on your carrier grade NAT. On the most ISPs, we are still getting one valid IP address each, but on the networks with larger number of subscribers, this is not possible. So you may see also this limitation. Again, see that from your phone, you can use something like Skype to connect to another person with Skype on her phone. How this is possible? Because when you are talking with Skype, you two are directly connected. This is called, maybe the last topic we are speaking about, this is called NAT traversal. It's traversing on the NAT. As you saw, your device is here, your NAT device is here. The issue is when you are going out, you are using practically public IP of the NAT device. So on the internet, you are seen by this. Nobody can directly contact you. There were some methods to overcome this. Maybe sometimes it's called pinholing. You have a pinhole here, say, okay, port 80 directs here. So whoever comes to my public IP address with port 80, forward it to my private IP address, port 80. This is pinholing, but it's very small, only for one IP, sometimes done manually, sometimes with protocols it's done non-manually. But you have to overcome this for most of the peer-to-peer networks, because the issue is someone else is living here. They also have one NAT device, and they are connected to the internet, and you two want to talk with each other. How this can be done? There are some protocols like STAN protocol. If you are interested, you can search for STAN RFC and read it. This is a way in which you can find your own IP address and pinhole here. But if you are both behind the NAT, there is another solution for NAT traversal, a server. For example, on Skype, there is a server here. Whenever you log in into Skype, it says, okay, you are Z connecting to the Skype. So it will remember that Z is connected with this IP address, and I can reach her with this port. For example, this is not the right port. Okay, when Jody connects to the Skype, you will connect to the Skype main server and say, okay, Jody is here, connected from this IP and from this port. This is just defined here, and it can be forwarded to your phone. Then what happens? If Z wants to call Jody, first the program will look up this server and sees, okay, Jody on this port, on this IP is reachable. Then calls Jody. This is how a middleman can help you to connect directly when both of you are behind the NATs. Also, if you are interested, search for STAN. And you will see one solution, one very public solution for this. Also, UPnP and other protocols are there to help on this one. I hope you understood the NAT. In the easiest way, it's network address translation, which translates your private IP to its own public IP and connect it to the internet. And when the return packets are coming, it remembers that, okay, this packet for what? For this user. So again, it will change the packet data, so you will feel that you are working with the internet with your own private IP. This was the NAT. Hope you enjoyed it and hope you learned.